Okay, so we are recording. So recording pages 4 through 6 of the 7-1 notes. And again, we're going to graph the general solution for the differential equation dy dx equals negative sine x. We know the antiderivative sign is negative cosine, so antiderivative of negative sine is positive cosine, and plus c. Excuse me. And we know this makes sense because the derivative of this is going to be negative sine x, and derivative of c goes away. And we're going to do this for 7 different c values, negative 3, negative 2, negative 1, 0, 1, 2, and 3. We're going to store as a list in the calculator. To access the list, the instructions are right here, but I'll show you in action use my TI Smart View. And we're going to type in as y1 equals cosine x plus L1. And we're going to use the zoom trig mode. That's going to be a proper window for trig functions. After that, then we'll come back and revisit these notes and fill all this other stuff out. But for now, let's just do more of a calculator demo. So let me minimize that. Okay. So let me clear this. So how am I going to do this as a calculator demo? Well, first off, you go to y1 and you type cosine x plus, and then to access L1, hit the second button. And notice all the buttons I'm pressing are right here. Hit the second button and then hit the left parentheses, I think. No, hit the number 1 right here. There we go. Hit the second and the 1, that's where L1 is located. Actually, I think the instructions in the notes are off. Yeah, I don't know why that's off. So to access L1, just notice right here. Second, and then number 1, that's L1. That might have been for the older calculator, perhaps, I don't know. Anyway, we have nothing for L1 just yet, right? We haven't defined L1 yet. To define L1, now I think the stuff in the notes is correct. Now I know what Mrs. Brantford was just talking about. Okay, I see. On the home screen, if you hit the second parentheses, you do the braces and you put as a set. I see what she's doing now. We could do it that way. I was thinking of doing it this way. So I don't know what L1 is yet. So I'm going to quit out to the home screen. Now I could do this. If I go to Stat and then Edit, I could type in L1 right here. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. For those who have done AP Stats, you are probably very familiar with this feature. Let me walk you through it again. Hit Stat. And by the way, it's all recorded. Edit. And under L1, tap those. If there's something you see right there, like if I were to hit the up key and hit clear, and then hit the down key, it clears everything for you. If you don't see an L1, like for example, let's say I did this, then just put it there. Just hit second 1, and it puts L1 for you. And again, I'll do it again. Negative 3, enter. Oh, why is it bugging out? Stat, edit. Okay, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then you can just quit out to the home screen. Now what Ms. Blanford was talking about was doing this. If you hit second parentheses and then typed in your numbers, negative 3, comma, and I'm just gonna put a random number like 5. Don't do this, by the way, and 8. And if I ended that, and I hit the store button, and then hit second 1 to call up L1, it stores as L1. If I hit Stat and then edit, you see that that's what happened. It changed it for me. So you have 2 places where you could do that. Personally, I like going to the Stat menu. I think it's just a little cleaner that way. So I'm going to go and clear that again. One more time. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now I go back to y equals. So what the calculator is going to do now is going to graph 7 different functions. Cosine x minus 3, cosine x minus 2, cosine x minus 1, cosine x plus 0, cosine x plus 1, cosine x plus 2, cosine x plus 3. Make sure your mode's in radian, which it is. Zoom, I like to do z trig. That way it goes from -2 pi to 2 pi for x and -4 to 4 for y. It's kind of a good window for trig functions. So I'll pick option 7. And you see it does the graph. It looks a pretty cool looking graph. So your graph should look like that. Now, this represents the graphical solution. So this right here, and it's going to be a little hard for me because I don't have a mouse for my Mac device. But this right here, so I'm going to do my best to write on here. Geez. Why you're not drawing? There we go. Okay. Yeah, you can tell Mac is not my wheelhouse, but I like how I do a lot of I do a lot of coding on this because it's a better device for programming. But so this represents the graphical solution. Actually, let me be smart about this. Let me do it as a text box. There we go. These graphs represent graphical solution for dy over dx equaling negative sine x. Okay, so you can see my text box I just put up. These graphs represent the graphical solution for dy over dx equals negative sine x. So that's what this represents. Now, let's go back to the notes. So sometimes you can't do it as easy as we just did for negative sine x. When you can't do it as easily, we do something called a slope field. So again, let's look at the differential equation, dy over dx equals negative sine x. But this time pretend that we don't know how to find the antiderivative. Again, we know it's cosine x plus c, but let's just pretend you didn't know that. So how would you draw the graphical solution for this differential equation? Well, the key idea is this. You take the slope at some point on the coordinate plane, and the things that dy over dx is the slope of your original equation, right? Isn't dy over dx the slope of a tangent? It is. At a particular x coordinate. So what you would do, and actually let me pause this recording because I'm now going to go on to back to my other device. So let me pause that recording. Or actually, I'll just, yeah,